Next, angle between two lines. Considering any two lines in a plane, they would be either parallel, right, any line. So the possibilities are either parallel or they are coincide, or they would be intersect each other, right? These are the possibilities. When two lines are intersected, they form two pairs of vertical opposite angles at the point of intersection, right? And any two adjacent angles are supplementary. That is true, right? So see, this is one line and this is another line. They are intersecting at the point, right? So opposite pairs, equally vertically opposite. This side blue color and green color, vertically opposite. So green plus blue, one pair, right? Take one pair of green and blue, so that they are supplementary. Angle is 180 degree, straight angle, correct? That is what sum of any two adjacent angle is 180. Adjacent means green and blue, right? Sum of the green and blue angles, you will get 180 degree. Let L1 and L2 are two lines intersecting each other with the slope m1 and m2 respectively. Let theta 1 and theta 2 are the angle of inclination of the line L1 and L2 respectively. So we'll see x dash y dash. O is the origin. First line L1 and line L2, they are intersecting, and L1 angle of inclination theta 1, L2 inclination that is theta 2. We know slope of the first line m1 is equal to tan theta 1 and m2 is equal to tan theta 2. That is equation number 1. Let pi be the angle between the lines L1 and L2. So this is the pi. Let L1 and L2 cuts the x-axis at the point A and B respectively. So L1 cuts the x-axis at the point A and L2 cut the x-axis at the point B. Let P is the point of intersection of the line L1 and L2. So point of intersection of L1 and L2 is P. Here angle PAB which is equal to theta 1, PAB, correct? And PBX is theta 2, right? Angle of inclination that is given. And angle APB which is equal to APB which is equal to angle L1P L2, right? So opposite, vertically opposite pair of angles, so right, that is equal to pi. So angle ABX right angle 180 degree. So P and PBA which is equal to, right, PBA which is equal to, so ABX full angle minus angle PBX, so 180 minus theta 2, that is 180 minus theta 2. We know the sum of all the three angles in a triangle is 180 degree. So in the triangle, right, in the triangle PAB, consider the triangle PAB, sum of the angles angle PAB plus angle APB plus angle PBA which is equal to 180. So angle PAB theta 1, APB pi plus PBA 180 minus theta 2, that is equal to 180. 180 in the left hand side and in the right hand side of the equality get cancelled. So you will get theta 1 plus pi which is equal to minus theta 2 equal to 0. Therefore pi is equal to, taking theta 1 theta 2 to the right hand side, so theta 2 minus theta 1, right? So taking tan on both sides, tan pi which is equal to tan theta 2 minus theta 1, that is equation number 2. We know tan A minus B, trigonometric formula, tan A minus tan B by 1 plus tan A tan B. So here A is equal to theta 2 and B is equal to theta 1. So 2 implies tan theta 2 minus theta 1 is equal to tan theta 2 minus tan theta 1 divided by 1 plus tan theta 2 into tan theta 1. So we know from the equation 1 m2 minus m1 by 1 plus m2 m1, right, where 1 plus m2 m1 not equal to 0. If it is equal to 0, this is undefined, right? So anything by 0 is infinite. that is why. So the possibility this values exist only if 1 plus m2 plus m1 not equal to 0. So case 1, if tan pi is equal to m2 minus m1 by 1 plus m2 m1, right? That is, if it is positive, right, the value is positive, pi will be acute angle, right? So case 2, if tan pi is equal to m2 minus m1 by n1 plus m2 m1 is negative, then pi is obtuse angle. Hence the acute angle pi between the lines L1 and L2 is given by, so we are going to take the modulus, right? Tan pi which is equal to m2 minus m1 by 1 plus m2 m1, as 1 plus m2 m1 not equal to 0. Therefore the acute angle pi between the line L1 and L2 is pi is equal to tan inverse of modulus m2 minus m1 by 1 plus m2 m1. Condition for parallel lines. We know angle between parallel lines is 0. So here pi is equal to 0, angle between the lines. So tan pi equal to 0, m2 minus m1 by 1 plus m2 m1 equal to 0. So cross multiplying 1 plus m2 m1 into 0, 0. So m2 equal to m1. Slopes are equal. For perpendicular line condition, we know angle between perpendicular line is 90, that is pi by 2. So pi is equal to pi by 2. Tan pi by 2, tan pi is equal to tan pi by 2. That implies m2 minus m1 by 1 plus m2 m1 equal to infinite. Some number is infinite, definitely the denominator should be 0. 2 by 0, a by 0, l by 0, 5 by 0, minus 3 by 0, everything infinite. So the possibility is 1 plus m2 m1 which is equal to 0. Therefore m1 m2 is equal to minus 1. Product of the slope is minus 1, right? General form. Consider the general form of the lines a1x plus b1y plus c1 equal to 0, that is equation number 1, and the second equation a2x plus b2y plus c2 equal to 0, second equation. Slope intercept form of 1 and 2. So we are writing it in the slope intercept form. 1 implies a1x plus b1y plus c1 equal to 0 implies slope intercept form, we know, right? So y equal to minus a1 by b1x minus c1 by b1. So slope of 1 is m1 equal to minus a1 by b1, and similarly 2, right? a2x plus b2y plus c2 equal to 0. It can be written as, that is slope intercept form, y is equal to minus a2 by b2x minus c2 by b2. Slope of the second equation is m2 is equal to minus a2 by b2. Condition for parallel. So if 1 is parallel to 2, m1 equal to m2. Therefore minus a1 b1 equal to minus a2 b2. That is a1 b1 equal to a2 b2. Therefore a1 b2 is equal to a2 b1, which is the required condition. Next, perpendicular. For condition for perpendicular. 1 is perpendicular to 2. That is 1 and 2 are mutually perpendicular. Then m1 m2 is equal to minus 1. That is minus a1 by b1 into minus a2 by b2 is equal to minus 1. That is a1 a2 by b1 b2 is equal to minus 1. So a1 a2 is equal to minus b1 b2. That is a1 a2 plus b1 b2 equal to 0, which is the required condition for 1 and 2 are mutually perpendicular. So next, some important points to remember. It is very useful to solve the problems, right? The lines parallel to ax plus by plus c equal to 0 are of the form ax plus by equal to k. K is a real number. Second one, the line parallel to ax plus by plus c equal to 0 and passing through the point x1 y1 is, its equation is ax plus by, which is equal to ax1 plus by1. You can write directly. If they ask if any line, they have given any line and passing through the point, then the parallel line passes through that particular point parallel to the given line is immediately you can write, right? Then perpendicular line to ax plus by plus c equal to 0 are of the form bx minus ay equal to k. See, note that bx minus ay, k is a real number. The perpendicular line to ax plus by plus c equal to 0 and passes through the point x1 y1 is given by bx minus ay is equal to bx1 minus ay1. If m1 m2 is equal to minus 1, then two lines are perpendicular. That is true, right? But converse is not true. That is, two lines are perpendicular. It is not necessary that that their slope, product of their slopes equal to minus 1. For example, right? For example, you can consider any two lines such that one line is parallel to x-axis and other line parallel to y-axis, right? But the result m1 m2 equal to minus 1 cannot be applied, right? Even when the lines are perpendicular. So they are perpendicular, right? Line parallel to x-axis and line parallel to y-axis. Y equal to a or x is equal to a. What is the slope? Find the slope and take the product. So this is not true, right? Slope, so y is equal to a means slope is y is equal to mx plus c. There is no x term, 0, right? So x is equal to a. What is the slope? Y, there is no y term, right? So you cannot find. So m1 m2 is equal to minus 1 cannot be applied for this. Next one, a1x plus b1y plus c1 equal to 0, a2x plus b2y plus c2 equal to 0 are given two lines with c1 greater than 0, c2 greater than 0. Note that a1 a2 plus b1 b2 less than 0, then the angles between them acute. If a1 a2 plus b1 b2 greater than 0, then the angle between them is obtuse. Thanks.